name is Sheina Pribadi, and I go to school at Jakarta Intercultural School, and I am in grade 11. And today I will be talking to you about the ACE project, which stands for Alternative Cement for the Environment. So first, my vision statement. I believe we can build a better Indonesia while lowering carbon emissions to slow down the effects of climate change. So how did I get to this? Well, first, I want to talk about the problem of pollution. So I guess everyone here knows about pollution. And I know that statistics show that Indonesia is one of the most heavily polluted countries in the world, and our air quality just sucks. But this is not just any problem. This was a personal problem. Every single day, I would get out of my car to go to school, or I would walk outside to the balcony of my apartment, and I would just see these gray, smoky clouds of pollution covering these tall buildings. And that was the moment when I realized that something had to change. So when I realized that alternative cement doesn't require you to trade off between being sustainable and providing a quality product, I thought that, hey, this could be the perfect solution. So I set out to create my own version of cement. But before I jump into that, a bit more about the problem. So first, cement is really polluting. And this is because in order to create cement, you have to go through this kilning process, which is where you have to burn things like limestone that actually make cement, and that produces a lot of carbon dioxide. Furthermore, on the bottom picture here, you can see these are coal-burning power plant factories. And not only do they produce a lot of greenhouse gases, but they also produce a byproduct called fly ash. And this is usually improperly disposed, which ends up polluting waterways and landfills. But before I go into why those things connect, my mission. My mission is to replace traditional polluting cement clay bricks with an eco-friendly, sustainable, and possibly cheaper cement brick. And to give you a perspective, here are some statistics. So for every kilogram of cement produced, for every kilogram of cement replaced by a kilogram of fly ash, we are preventing 0.9 kilograms of CO2 from being emitted. Furthermore, the cement industry is responsible for 8% of global emissions, and that's about 1.7 billion metric tons of CO2 emissions annually. Furthermore, in regards to fly ash, more than 65% of fly ash produced is disposed to landfills or waterways, which end up polluting ecosystems. So, what is the solution? To create fly ash cement bricks, which solve the problem. So I can give you 4 reasons why these fly ash bricks can be better than regular cement bricks. Number 1 is it's more beneficial for the planet. So since we are using a waste product from coal burning factories, not only are we reusing a waste material that otherwise would have been improperly disposed and pollute waterways and landfills, but we are also creating a brick that is more eco-friendly and sustainable. Furthermore, since we are replacing the majority of cement with this fly ash, we are reducing the carbon dioxide produced through the manufacturing of cement. And also there's scientific research to prove that through using fly ash in your bricks, you will be saving more water in creating the bricks, so therefore you are preserving a scarce natural resource. Next is it's more beneficial for construction. So there is research to prove that fly ash is known as an enhancer, so therefore it will increase the strength of regular cement bricks. Furthermore, these fly ash bricks are more durable and absorb less water than regular traditional Indonesian clay bricks. Furthermore, you can reduce thermal cracking, which is when the bricks crack due to the reaction of elements in cement, and it leads to increased strength as well as better cohesion, so there's less rock pockets and there's less air pockets, which also leads to an increase in strength. Furthermore, it is economically beneficial. Since fly ash is a waste product of these coal burning factories, you do not have to manufacture them like cement, so it's automatically cheaper. So therefore, if you use this fly ash to replace your cement in these bricks, you are cutting down your overall costs in creating a brick. And lastly, sustainability. So as long as we have these coal burning factories, then we would not have to worry about running out of this fly ash because it's a waste product of these coal burning factories. So more about the prototyping process. So after the research stage, I decided to experiment and create cement. So I got a bucket, I got a shovel, and I decided to annoy my mom and make a mess in my balcony. So basically, I created multiple different types of formulas. I decided with my top 9 formulas, and I tested these top 9 formulas in a university lab using a strength compression test. And based on these results, I decided to move forward with the strongest cement brick. Then afterwards, I decided to go expand this project even further and decided to test these bricks in regards to the current Indonesian environment. So I went to a local workshop and I decided to manufacture 4 types of bricks. My formula bricks and regular cement bricks, a clay and fly ash mixture brick, and the Indonesian traditional clay bricks. And this was to build a 2 meter by 2 meter house to see which of these bricks could best withstand the current Indonesian environment. So first, I would like to address some limitations. Of course, this is just an experiment, and there could always be more data, more research to prove the advantages of this fly ash brick. But fly ash does come with some potential problems. For example, compared to Portland cement, fly ash bricks tend to have a longer curing time, which means that it takes more time for these bricks to dry in order for you to use them. And furthermore, it really depends on how you mix these bricks and your formula, because it could also lead to a decreased strength. And finally, the next step. So Indonesia is on the ring of fire, and I have experienced 3 earthquakes this school year. And my experience is nothing like those who lived in communities where their houses tumbled over and their roads broke apart. Therefore, my family has the resources to repair any of these damages, but people in these communities tend not to have. Therefore, I decided to expand this project, and I decided I wanted to help these people with my bricks. So I wanted to further implement the solution in the real world by helping communities affected by recent earthquakes in Indonesia by renovating or rebuilding their sidewalks with my bricks. And therefore, you can support this cause by scanning this QR code or contacting us through Instagram or email. But I want to conclude with this. Even though rebuilding these sidewalks may seem like a small step in order to make a huge impact in our community, just like this tiny cement project, a tiny change in the cement formula can make a huge impact in the environment. Thank you for listening.